The stage is yours, Alex.
Awesome. Thank you, Daniel. Yeah, so, as Daniel mentioned, this is talking to me about serverless. And if you've been around sort of the application development space in the last couple of years, you've probably heard about serverless applications, things like that. And that really got started in 2014 when AWS announced Lambda at reInvent that year. And Lambda is this pretty interesting new tool you have where you can just, you upload your code and it runs wherever you want in response to events. So which is pretty amazing. But again, you need events to sort of kick that off. So you have something like, maybe Amazon API Gateway, which hooks up HTTP endpoints to your function. So when people call HTTP endpoints with a get or a post or whatever, it can invoke your Lambda function. You'll do something with it and return to it. But just the code itself and API gateway, that's not enough. Usually you need some sort of other service, which could be Amazon S3. Maybe you're storing or retrieving blobs of data, or maybe a queue service, right? You're queuing some data in something like Amazon SQS, or it could be on any other number of services, EventBridge, Kinesis, SNS, things like that. But really, at some point, you're probably going to need a database, right? And if you're working within the Amazon world, there are a couple different database options. You have RDS, DynamoDB, DocumentDB. And that's what this talk is about. It's about choosing a database for serverless applications, because a lot of things about serverless are different than what came before it. So you need to consider some different factors when you're choosing that database. So I want to talk about a few different things today. First of all, we'll just talk about, your options in terms of data model. And I think, that's not super important, but the big point there is it just introduces the different database options that we'll be covering in the rest of the talk. The other three factors we'll have is, how managed is this database and how does that fit into a serverless world? Also, serverless integration. How well does it work with some of the quirks of serverless that are different, from running on instances or containers? And then finally, we'll get into the pricing model and how well that sort of fits into the serverless ethos. So who am I? I'm Alex DeBrie. I wrote the DynamoDB book, so I'm very biased in some sense in this talk. I like DynamoDB quite a bit, but I'll try and be fair and at least give you some of the pros and cons of DynamoDB and the other databases. I also created DynamoDBguide.com. I'm an AWS Data Hero and just a general AWS and serverless fan. I mentioned the DynamoDB book. If you come away from this thinking DynamoDB is the one you want to look at, go check out the book for sure. It's a pretty comprehensive guide to data modeling with DynamoDB with lots of examples, all sorts of things. So you can go sign up, get a free preview if you want. But let's hop in and let's start with, the different data model options you have and really the overview of just the sort of different options within those data models as well. So when we talk about data model, I think the big elephant in the room that you hear about a lot is going to be SQL, right? The traditional relational database. A lot of people know it. A lot of people use it. So let's talk about the pros and cons of SQL. First of all, a big pro is going to be familiarity. A lot of your folks, whether they went to code school or university or self-taught, whatever, they've probably used SQL in the past. They know that relational mindset, right? And they've used it at other companies, things like that. So it's going to be familiar. People know how to use it. Good library support, things like that. Also with SQL, you get really good query flexibility. So if your data access patterns change over time, you've got that data set up in a normalized way that you can, write a new query and handle new access patterns in your applications. Some of the cons around SQL is, it's going to be a little bit harder to horizontally scale than some of the other options we talked about before. It's harder to shard your data. Although I would caution you a little bit there, that's not a problem for a lot of people. SQL databases are really good now. They scale up really far. There are certain people, Amazon, Uber, Lyft, whoever you're talking about there, that really do need the scale that NoSQL can provide. But a lot of people can get by with a SQL database. I think sort of more subtle about this is the scaling points are less predictable in a relational database. There are so many different parameters you can tune with a SQL database, or maybe different query optimizations you can make, or you don't know which sort of queries won't perform well. If you're doing big aggregations, they might work well at the beginning and not work well later on, where NoSQL is going to be a little bit more explicit in sort of how that scales. So I think that's one of the cons of SQL there. If we talk about the different options we have here, you can think of sort of the old guard options, proprietary databases. You see Oracle, SQL Server. I don't see a lot of that in the serverless world, just because, if you're using serverless, you're using a lot more, greenfield, newer tech usually. So usually choosing something like open source databases like MySQL, PostgreSQL. Like Daniel's joking about the elephant in the room, Postgres it's got the elephant logo. So these are pretty common with more modern applications, these open source ones. If you want to talk sort of in the middle here, you could look at Amazon Aurora, which is going to be a proprietary database that's only offered by Amazon. You have to, sort of use it as a service from them rather than running it on-prem or even on your own EC2 instances. But it does speak some of those open source dialects like Postgres or MySQL, so you can get those flavors if you want. So that's the lay of the land in terms of SQL databases. Let's look at the other sort of data model option you have here, which is NoSQL. And that's really a grab bag for a lot of different database types. That could be as simple as key value, but it could also be document databases, wide column, graphs, different things like that. Let's go through pros and cons of this type of database. So one pro might be, schemaless, right? You don't have to sort of declare all your schema up front or do migrations to add new columns, things like that later on. Some people really enjoy that. Also, it horizontally scales pretty well. So if you do have a lot of data or very high velocity data where you're going to need to scale pretty high, this is going to work well for you. And again, the scaling is easier to comprehend if you sort of understand 2 or 3 concepts about this database. You can really tell where it's going to break and things like that, and set yourself up for success in that way. The cons about a NoSQL database, again, sort of the flip side of the pro here is it's schemaless, right? So you don't know, it's hard to know what sort of data is in your database without really looking at it, in contrast to a relational database where you define the tables, define the columns, things like that. Also just generally less well known, right? You're probably not learning it in school or code school, whatever you did there. Maybe you haven't learned it at a prior company. And I also think there's a lot of bad NoSQL material out there, so you might go down the wrong road and really do something wrong there. So there's a learning curve there for sure. Finally, it's also harder to do like OLAP queries. So OLAP being sort of like large scale analytical queries, So if a PM or a biz analyst or something like that in your company wants to say, hey, what's the top selling item last week? Or who are our top 5 customers over the last 3 months? Easier to do in a relational database than a NoSQL database and things like that. So that can be a little bit of a downside as well. In terms of the options that I see in sort of a serverless application that I'm going to put down 4, one is going to be the sort of big NoSQL one that everyone thinks of, which is MongoDB, right? It wasn't the first NoSQL database, but I think it was the first really popular NoSQL database, and that's a document store, very popular. If you want to go something in the AWS realm, you can look at DocumentDB, which is basically Amazon's own version of MongoDB. It's compatible with MongoDB, the format there, but it's more of a self-hosted solution or a fully managed solution from Amazon there. You can also look at DynamoDB. Again, that's the one that I've written books on and things like that. That's what I prefer. Again, within the Amazon ecosystem, more of a sort of a wide column store than a document store, but really good for a lot of things, picking up popularity. If you want to do a comparable one that's outside of the AWS Amazon ecosystem, then I'd look at Fauna, which is going to be similar to DynamoDB, has some interesting global features there as well, and some other features that are pretty interesting. So those are the options for NoSQL. Again, SQL, NoSQL going to be the 2 different types of data models you can think about. Let's look at our first sort of factor that you really want to consider, and that factor is how managed is it? And to do that, before we get into it, I want to talk about like what I mean when I'm talking about managed and why that's so important in your serverless applications, why people are really liking that. So first of all, what I mean, maybe one aspect of fully managed is failover, recovery, backups, all that stuff is handled for me to where I don't have to think about it. And the reason that we're so concerned about that in the serverless world is that's undifferentiated heavy lifting, right? My company, my project, it's not going to succeed because I do failover and recovery better than anyone else. It's going to succeed because I have better features and a more interesting community or whatever it is than anyone else, not about sort of under the hood database stuff, right? So let's offload that to really good engineers, whether that's at AWS or Mongo or somewhere else, to run that for me, and I can focus on delivering the features that really matter to my customers. Another aspect of managed that's nice is just getting automatic updates. And why this is so important is like services improve without me upgrading, right? I don't have to log into my EC2 instance and stop my old version of Mongo and start my new one to get these new features. It's sort of just updating all the time, getting better for me, getting faster. With Lambda, that could be just the improvements they've done with cold start, things like that, the improvements they've done around billing time calculation, just all sorts of things. Lambda, SQS, those are all getting better for me all the time. I like my database to do that as well. Last thing we talk about with the what and why manage is auto scaling and pay per use pricing, right? And the big key here is I want to pay per for value rather than pay for capacity, whether I'm going to use it or not. And we'll talk about pricing model a little bit more later on as well. So with those sort of principles in mind, let's look at how these databases line up, across a continuum here. On the far right, I might have fully managed. This is the ideal, what we want in that serverless world. On the far left, we have YOLO, right? You want to do it yourself. You're a cowboy. You don't want anyone managing it for you. You think you can do it yourself. On that far left, we have Amazon EC2, right? You can run your own instances, or maybe you have something on-prem and you're installing the software on it and running it yourself. I would highly not recommend that. Whether you're doing serverless architecture or something else right now, I think there are just so many good managed database options that you don't want to be in the business of really truly managing your own database in almost all cases, I think. So then if you move a little over on that continuum, you have what I can consider, the mostly managed databases. And this would be things like Amazon RDS. That's relational database service. That's going to run MySQL, Postgres, Oracle, or Microsoft SQL if you want something like that. You also have Amazon DocumentDB or MongoDB Atlas, which is a service from MongoDB that runs its database for you. These are really great in some sense. I think it gets you out of that EC2 world. This is really great. It's going to do a lot of that sort of failover and backup and recovery, all that stuff for you. But it's still not quite all the way there. To do updates and things like that, you might have to click a button in the console to do an upgrade. You still need to think in terms of instances and maybe add more instances or remove instances, things like that. So you're not quite in that fully managed realm yet. Next one over would be one called Amazon Aurora Serverless. This is a new-ish one. So they've had Amazon Aurora. They also have this serverless flavor that scales the compute up and down. They had a V1 version of that was just okay. V2 version just sort of came out at reInvent. It's still pretty new, but it's pretty promising and interesting there to where you get closer to that fully managed world. And then if you want to get all the way over on the right and really into that fully managed, that's where you see things like DynamoDB and Fauna that were really built for this serverless world. You don't have to worry about upgrades. You don't have to worry about pre-provisioning capacity and paying for idle and all that stuff. They're going to handle all backups and failures for you. You don't think about instances. So it really is, I think, the ideal if you're talking about serverless databases, those two, in terms of how managed they are. Let's move on to the next topic, which I'd say is like serverless integration, right? And again, serverless compute and applications are a little bit different than the previous world. So some of the existing databases and infrastructure don't quite fit as well in that world. So let's talk about some of those specifics and see how our databases fit in here. I think the first thing that's interesting to talk about is infrastructure as code, right? And this is a pattern that's been around before serverless started, but it's basically saying, when you're provisioning your infrastructure, your instances, your database, your S3 buckets, all that stuff, do it as code in this, often declarative way where you can spin up the entire thing and rather than someone going and clicking in the console and creating something, and now you have no repeatability around it. So infrastructure as code has been around for a while. I think the serverless world particularly has really embraced infrastructure as code. And part of that is because with these serverless applications, your infrastructure is part of your application in a way that it might not be if you're using instances or containers. If you're using managed services like SQS or S3 or Kinesis or things like that, it really gets some application mechanics into your code that infrastructure does, and it's really important to sort of provision your new application code with your infrastructure altogether. In terms of like tools for infrastructure as code, I would say there are two really big ones. One is CloudFormation, which is an AWS tool and covers a lot of AWS services, but is not going to be so great at third-party services. And then one is Terraform, which is a third-party tool from HashiCorp. They do AWS, but they also do Google, Microsoft, but also sort of anything you want, Fauna, MongoDB Atlas, all that sort of stuff, which is really nice if you're outside of the AWS ecosystem. I would say for most of the serverless stuff, and again, this is coming from Lambda bias here, I would say most of the tooling has consolidated around CloudFormation because of the way some of the tools have packaged up your application code with your infrastructure as part of deploying that. So CloudFormation is generally the tool of choice for serverless Lambda-based applications. But again, you can use Terraform if you want. Based on that, I would say, if you're using CloudFormation, you might want to prefer AWS native databases over third parties. So things like RDS over getting your managed relational database somewhere else, or Amazon DocumentDB over MongoDB Atlas. Again, just for that infrastructure as code part, not that it's a total deal breaker. The other thing I would say when you're thinking about infrastructure as code is, prefer databases where you can do your full provisioning using that infrastructure as code rather than just partial provisioning. And the example I give here is, even if you're using something like RDS, or relational database service, you can set up a relational database using CloudFormation and get that all provisioned. But even after that step, there's something you need to do with inside that database that you can't do within CloudFormation. You need to connect to that database and create users and roles and permissions, create your tables, create your indexes, triggers, whatever it is, all that different stuff. And that's sort of outside CloudFormation. So it takes like a different steps. You sort of have two different provisioning mechanisms going on. You can contrast that with something like Dynamo, where you can create the table, you can create your secondary indexes, you can create users and give them permissions on your table, all that stuff within CloudFormation. So all your provisioning is in CloudFormation in a single tool rather than sort of having two different tools, two-step process, things like that. So in that sense, you might want to prefer Dynamo over RDS. The second factor I want to talk about with serverless integration would be auth, right? So how do you connect and talk to your databases? And if you're talking about the older, more established databases, relational databases, things like that, that's going to be username, password authentication, which is fine. But now you need to sort of store that credential somewhere. You need to rotate it. You need to make sure you're managing access to it and things like that. Whereas, if you're using Lambda and you're connecting with other AWS services, S3, SNS, SQS, whatever it is, you're probably attaching an IAM role to your Lambda function that gets, temporary credentials just injected in that are limited to the access you give it. And you can use those automatically without having to really think about them in your code. If you're using DynamoDB, you can do the same thing, which is really great. So with auth, prefer services where you can use IAM over sort of username, password, manage credentials that you have to handle. Just again, it takes something else off your plate and allows you to scope it down a little easier, I think. There are a couple of relational databases within AWS where you can use IAM as well, so you can check that out. Last thing I want to talk about with serverless integration is the connection model, right? How do you actually connect to the database? If you're working with a traditional database, like a relational database or even Mongo, things like that, you often set up these long-lived TCP connections to your database and reuse those. And that worked great in the world of instances or even containers where you're sort of spinning up this instance, preparing it, and then it's going to be taking lots of different requests. But the problem is with Lambda, you have all these little tiny compute instances spinning up all over the place. They're event-driven compute, which means they're only called and spun up when something actually has to happen. So you don't want to spend the time setting up this TCP connection, doing things like that. Also, you have to run into connection limits, right? A lot of databases, Postgres, MySQL, will limit the number of open connections you can have because it takes memory on the server to have those connection limits. So Postgres, MySQL might have 100, 200 connections they allow at one time. Which means if you have too many Lambda functions spinning up all over the place, you can actually hit your connection limit and not be able to connect, which is a huge disaster. This is partially solved with another tool called AWS RDS Proxy, which is basically like a connection pooling instance that you can connect to, and that's going to manage connection to your database. It's like a PG bouncer, if you've heard of something like that. You can run your own one of these. This is sort of newish, so again, test it with caution, but that can help solve this limit. Even if you solve sort of the connection limit issues, you still need to consider things like VPC, security groups, ports, all sorts of access like that. So you're locking down your database to just the IP addresses you want. It doesn't quite fit really well within a Lambda world. You can put Lambdas into VPC and give them security groups, but there's some clunkiness around that. So there are some issues with traditional databases with that sort of stuff. If you're working with DynamoDB or also Fauna, it uses HTTP connections, which means you don't need to worry about connection limits, right? They've got basically a front end and that proxies to Dynamo, and it can handle as many connections as you want. You also don't have to worry about long-lived connections or connection limits. You don't have to worry about security groups and networking, all that stuff. That's all done over HTTP, and the authentication is IAM, so you don't have to worry about it. Fauna, very similar. So again, a nicer sort of connection model for this stuff. Last factor I want to talk about is pricing model, right? And in your serverless world, serverless architecture, you generally prefer pay-per-use pricing. And a lot of very common services in the serverless world are all going to be pay-per-use. Lambda, you're basically paying based on how much memory you've allocated and how much time your function actually runs. SQS, you're paying per message. API gateway, you're paying per HTTP request, things like that. Where pay-per-use is difficult, then you prefer something like easy auto-scaling. Maybe pay-per-use isn't doable, but if you can at least scale up and down as your traffic sort of ebbs and flows over the day or week or month, that's really great. So again, let's look at our databases on a continuum from how well they do pay-per-use versus not. So let's start with sort of instance base on the right side, which is going to be more like how you pay for EC2 or things like that, where you're saying, hey, give me this size instance, at the beginning of the month, and at the end of the month, they'll send you a bill for how many hours it was running. On the far right, we have pay-per-use, which is going to be more like Lambda, SQS, anything like that in this sort of native serverless world. A lot of databases are going to be in that instance-based world. Amazon RDS, Amazon DocumentDB, MongoDB Atlas. You're going to tell them how many instances and how big, and they're going to run that for you and charge you per hour. And it's fairly hard to scale up, and it's even harder to scale back down just because of how these databases work. So you're going to be sort of stuck a little bit. You're probably going to be overpaying for capacity because you're not going to get sort of full usage out of that just to make sure you can handle spikes. More in the middle will be that Amazon Aurora serverless, which we talked about before, which allows you to sort of scale up and down your compute in response to actual traffic that you have. Again, the V1 version was a little slow in how quickly it did that. Not great for a lot of production use cases, but the V2 version seems to be better. I'm still sort of crossing my fingers here, but check that one out if you want something a little more flexible, but you still want that relational model. Then on the far right side, again, we have DynamoDB and Fauna, which both have pay-per-use pricing. You can actually just do on-demand pricing and say, hey, just charge me for every read and write that comes in. You don't have to pre-provision stuff. It's going to handle all that for you and pay you for each read and write request that comes in, which is pretty amazing. So that sort of concludes it. I'm going to summarize it and give you the sort of TLDR. So again, just to review what we did here, first we looked at the data model and just sort of different options we have in terms of databases. Then we looked at three big factors, right? How managed is this database and how much do I have to do? How well does it fit into the serverless ethos that way? And then serverless integration, right? Lambda and those other services, they have some quirks around how they work compared to container-based, instance-based stuff. So how well do these databases sort of fit into that serverless world? And then last one, pricing model, right? We really like pay-per-use, pay-per-value in that serverless world. How well do these different databases fall into that? If you just want to know, hey, you gave me all that stuff, but really, what should I choose? Again, I'll try and be fair here. If you want to go the most serverless native, I'm gonna recommend Dynamo. I think it fits really well in terms of the connection model, in terms of how it scales up and down, in terms of the pricing, the IAM, the provisioning, all that sort of stuff. I think Dynamo works there. But again, I'm biased. I'm the Dynamo guy. But I think you are going to have to learn some things, learn some new things if you're using something like Dynamo as compared to relational, and it doesn't fit for all use cases as well. So if you want to go like most familiar and say, hey, we want to be productive right away, we want to get going, all of us developers already know SQL, then use something like RDS and maybe RDS proxy, right? It's RDS, it's still in the AWS ecosystem, you're getting all those benefits. RDS proxy is all managed for you. It can sand off some of those hard edges around connection pooling, stuff like that. That can work really well for you. I think that's a nice, safe, conservative pick there. If you want to go more cutting edge, then you can check out Aurora Serverless, especially that V2 has some pretty interesting scaling characteristics. Look at Fauna as well. They're doing some really interesting stuff with like global database type stuff and what that looks like with the global consistency. I think they're doing some really interesting stuff. You're stepping outside that AWS world, so you're going to have some edges you need to work on there, but I think they're doing some interesting things. If you do want to look into Aurora Serverless V2, I would highly recommend Jeremy Daly's post on this, that he just really did some interesting scaling look at that and what that looks like, how that improves on V1. Super interesting. So make sure you check that out before you dive in. And yeah, that's a summary. I can answer any questions if you want to check me out on social or my different resources. Check those out. But other than that, yeah, happy to answer questions for a few minutes before we move on to the next talk.
Alex, thank you so much for the insightful talk. I think we had a couple of questions come in from the audience, and I think the first one touches on real-time and kind of like having open WebSockets type functionality. So Ahmed asked, I don't know if you can see the question, if I'm making a social media app like Twitter where there is some real-time stuff happening, is serverless the way to go, or should I stick to traditional serverful?
Sure. That one depends a ton just on the specifics of the use case. If you really want to use something like WebSockets and you're maintaining this open connection, well, AWS does have a WebSockets mechanism for connecting, basically API gateway to Lambda and doing WebSockets and broadcasting sort of both ways there. So you can check that out. In terms of other real-time features, are you doing polling versus are you doing sort of stream-based stuff and broadcasting? I think there's a lot of interesting serverless stuff there. It's hard to give a generic recommendation like that because even Twitter, I think that's doing polling. It's not sort of doing WebSockets, things like that. So it depends on what sort of use cases you want. But I think a lot of the building blocks are there in a serverless world if you're willing to pick up how that stuff works. Great question.
Now, we had another question, which I think is going to be a bit difficult to answer, but someone asked, Daniel asked, I deployed a serverless Lambda app connecting to a database hosted somewhere else. The performance wasn't really great because new DB connections needed to be established for every request. So this is one of the more common problems that come up in serverless.
Yep, sure thing. So again, it's going to depend a lot on sort of what that database configuration was. I can give you a couple examples there. Like if you're using DynamoDB, I said, you need that's HTTP connections. Well, establishing that initial TCP handshake can be not super slow, but it's going to add 100 milliseconds or two on each request. If you sort of reuse that connection, it's just going to happen on the first request, and then everyone after that for your Lambda will be faster. If you're working in a serverful world, right? If you're doing an instance-based database like Postgres or Mongo or something like that, it could have been. This is getting kind of deep in the weeds, but if you had to put your Lambda function in a VPC so that you can allow like security group access and lock it down IP address wise, there used to be this cold start penalty for Lambdas in VPC where it would take a long time to do that, specifically if it's in a VPC, which I wouldn't recommend doing. They've made some improvements around that, so that could be faster now, but it could just depend on what your database is and some of the quirks around that. If you have like more specifics on that, like hit me up on any of these places and I'm happy to like give more advice on that. But hard to say without knowing specifics of the details there.
Yeah, and probably on the note of like generic advice in this context, I would probably say deploying them in the same region is like the very sort of high level recommendation that I would make.
Yep, absolutely.
So very interesting. So you've written this DynamoDB book and you seem to have quite a lot of experience with it. Yeah. As someone who's so familiar with it, what are some of the disadvantages that you sort of see beyond just level of familiarity and having, using a proprietary technology?
Yep, sure thing. So I think that's the big one is just like familiarity. Like people don't know how to model in a NoSQL database, and especially one that's like Dynamo. So I think they try and do it like a relational database, and that ends up really hurting them. So that's one thing. Two other ones I would say is it's not going to be quite as flexible as maybe a relational database. So if you have changing access patterns, it can be a little harder. You might need to reshape your data a little bit and sort of do some modification of the records in your table. Also, if you have access patterns that are I would say like if you're filtering on a ton of different attributes or maybe like more than 3 attributes and all of them are sort of optional, it can be hard to sort of map that into DynamoDB. So imagine you had like a CRM that had all these different categories: last name, first name, age, location, have they use this service, different things like that. If you want people to be able to filter on all these different categories, it's not going to be as great for that. It's more for like specific known queries. So make sure you're researching around that. I would say in general, it can handle 80 to 90% of the use cases really well, and just make sure with those other ones, like, can you work around it? Do you need to use something else, or sort of what's the situation there?
Gotcha. Thank you for that. And one final question: is it possible to spin up some kind of like a local development instance of the DynamoDB?
Yep. Yeah. So DynamoDB actually has what's called DynamoDB local, which is like a little Java jar that you can just like run locally and use it you can use it in your sort of local integration tests if you want to, or just as you're developing. It's not going to have all the features. It's got most of sort of the API implemented, but it's not going to have the availability features and things like that. But it does give you a nice way to sort of develop against that API locally without charging, and also without having to like sort of create and destroy the infrastructure all the time.
Gotcha. Well, Alex, thank you so much for coming here and giving this talk, and I hope to see you soon at perhaps another meetup.
Sounds great. Thanks for having me, Daniel.
All right.